Okay, now after we saw the overloading, let's now implement the overriding. And note that overriding is always coupled with inheritance, like as we said in the comparison between overloading and overriding, that overriding happens in two classes that have inheritance relationship. So without inheritance, we cannot implement overriding. For this, I will create two classes that have inheritance relationship, and then we will create a method inside the parent class, and we will try to override this method in the child class. For this, here I will create a new class. I will call this class animal. Okay, this animal will be my parent class, and I will put a, a method in this animal class, public void move. Okay, inside this move, I will simply print a statement telling that this animal can move. Okay, so this is my parent class. Again, I will create another class. I will call it turtle. Okay, if I come here in the sorry, in the main method, okay, just comment. If I create a new object of the turtle class, I call it turtle, and then new turtle. Okay, as you can see here, using this turtle object, also I forgot to say this turtle extends animal. So once this turtle inherits the animal class, okay, it inherits all the members of the animal class. So here, using this turtle object, I can call the move method. So if I run, I will get the output this animal can move, which is true, like turtle can move. But we all know that turtle move slowly, okay? It doesn't move normally, it doesn't move fast. It moves very slowly. So for that, I need a certain implementation for the move method, okay, inside the turtle class without changing the name of the method move, or without changing the data type, the return type of the move class, move method, or without changing the parameters of the move method. I don't want to change anything in the move method signature apart of the implementation. I want a specific implementation inside the turtle class. So how can I do this? I can override the move method inside turtle. So here it suggests me to override the move method inside the turtle class. In the animal class, my method move, it was public, void, and takes no parameter. Again, as you can see here, this animal move is public, void, and takes no parameters. So to make this method overridden in the child turtle class, I should do exactly the same. So here I have again public, void, and move is taking no parameters. This way I can override the moves. And here don't forget this annotation called override. This to tell me that I'm overriding systems. Okay. By default, this super.move will again call the same implementation as is in the animal class. Like here, if I run my program again, I will see no change. This animal can move. Now I want to apply changes to the implementation of this move. So I will simply remove the super.move code and I will put my own implementation, which is done specifically only for the turtle class. So here I can say this animal can move, but very slowly. Now, if I run my program one more time, I get the different result. This animal can move, but very slowly. And of course, this didn't affect the animal class. Like if I go to the main method and I create an object of the animal class and using the animal object, I call move, I will get the normal move that this animal can move. Look, this animal can move, but very slowly. This one I get for the turtle, but for any other animal, I get this animal can move. You understand?
Mm-hmm. Yeah.
Okay, fine. Now, if I create another class, I will call it rabbit class, and I will make this rabbit class extends animal. Okay. This way, if I create an object of the rabbit class, new rabbit, okay, dot move. What I'm gonna get as a result, I will get this animal can move. It inherits exactly the same implementation of this animal. Okay. Again, I can override this move inside rabbit. If I keep the super.move like the default behavior of move inside the animal class and I run my program, again, I will get the same. This animal can move. Like here, the only different result I get is on the different implementation, I get it only for turtle. This animal can move but very slowly. I made this certain implementation inside the turtle. Okay? And now I can do the same also for rabbit. Here in the rabbit class, I will if you know, I will override the implementation and I will go rabbit can move very fast. Now we run. For the turtle, I got this animal can move but very slow. Then for any other animal, for the parent class animal, I got this animal can move. And for the rabbit, I got rabbit can move very fast. You understand?
Yeah.
So this is simply the override uh, principle. So we covered both overloading and overriding, which are types of polymorphism. Now I'm done discussing the polymorphism. Let's go back one more time to
Okay.
the comparison class.
Yeah.
Do you see my screen?
Yep, I do. Yes.
Okay, wait. So now, after we are, you know, after we made some code examples of overloading and overriding, let's review the comparison between overloading and overriding. Overloading increases the readability because, as I told you, when we put the three methods called add with exactly the same job, but we just changed the parameters. Okay, first took two parameters, second took three parameters, third again took two parameters but with different data type, float instead of integer. Okay, all of them do the same job. All of them add the parameters, returns the result. It doesn't make sense to change the name. And if I change the name, it will make confusion. Keeping the same name will make the program readable. Okay. Overriding it was also useful because here I have animal, I have some children for this animal, and each child it may need a certain implementation for some methods that got inherited from the parent class, from the animal class. So, for instance, the turtle is moving very slow. So I get override the method move in the turtle to be specifically for the turtle, and I said this animal can move very slow. Again, I did the same with rabbit. Rabbit can move fast. So I made the specific implementation for the move method, okay, in the rabbit children animal, and I said rabbit can move very fast. Okay. Mm, Overloading done
Yeah.
with the same class. Overloading is done within the same class, as we already saw. The three or four methods called add, all of them are in the class calculator. I didn't move out of calculator class to do overloading. It's achieved within the class calculator, right? So it proves the
Right.
point of this comparison. Unlike the method overriding, I had to make inheritance between multiple classes. So we saw I created animal, turtle, and rabbit, three classes. Okay, they are related with inheritance relationship, which made me able to implement override. Without this inheritance with multiple class, I couldn't achieve override. I have no ability to override method within the class, but in child class or subclass. Okay. Also about the parameters. In overloading, when I created multiple methods called adds, I had every time I add a method with the same name add, I had to change the parameters. First, I had two parameters of type integer called a and b. Second one, a, b, and c. Third one, again a and b, but instead of integer, it's float. So each time I add a new method, I have to change the parameter. Unlike in the override, I had the method move. Okay, so to override move, I had to do the move exactly the same as it exists in the parent class. So it was public, move was public. I had to make it also public in turtle and rabbit. Move was void in the animal class. I had also to override the move. I make it void in both turtle and rabbit. Okay, move originally take no parameter in the animal class, in the parent class. In turtle and rabbit, again, it doesn't take any parameters. So if I made any change in this method, move, okay, it will not be overriding it. Like in rabbit class or in turtle class, if I try to make a parameter, make move take a parameter, which doesn't exist in the animal class, this is like no longer override. Okay, you understand?
Yeah.
Okay, great. Now I'm done. Please tell me if you have any questions.
Uh, Not yet. I don't think I have any question right now.
You don't have any questions?
I don't think so.
Okay, great. So I will end the meeting now, and